Okay, so you start on this full stack instant response page that you got to at samsclass.info, and then click on the first one, threat hunting with Splunk. What's going on here, Splunk is Google for log data. It is the standard, it is the gold standard, it's the most expensive and most desired tool for incident response because it makes it very easy, comparatively easy, to track down security problems. As we'll see, it can be confusing, but the confusing thing is not Splunk. The confusing thing is the nature of log entries. So I put a couple of servers in the cloud you can use. They have a username and password of student1. So if I click this, there's two servers, although one would probably be enough for this class, student1, student1. They're both the same. And when you sign in, you see the Splunk page. And let's see if it opens. Yeah, it does open. All right, you go to the search and reporting is the only thing we're going to use. And it is more or less like Google. You just enter a search query, and then you can search through events. And you see here what it has. It's preloaded with about 1 million events from a real server. This is something Splunk prepared for us to use for training. And it is, they set up a company in the cloud with an email server and a domain controller and a web server and other things. And then they attacked it in various ways. And they recorded all the events and made it publicly available. So if you go to the data summary, you'll see the type of data that exists. And here you see the name of the host, which is the machine which provided the log files. And that's not really very useful unless you understand the various servers at the company. What's more interesting is sources or source types. Here you see a more descriptive information of the type of data. Here's Suricata, which is an intrusion detection system. Here's Microsoft Web Server, INET pub logs. Here's some Windows event logs, like the security log and the system log. Here's some registry events. Then there are some scans. I'm not sure what those are about. Here is stream data. Stream data is Splunk examining the network traffic. Now, it doesn't record the entire packets the way Wireshark did. It more records just the total amount of data sent from one place to another and some metadata, like NetFlow, Cisco's NetFlow would. But anyway, they have HTTP data and IP, TCP, and UDP and DHCP data recorded off the network traffic. And then those are the Splunk stream data that we have. So these are the different sources we have from different objects on the network that are providing data. And you can then search for them up here. Now, let me go back to my instructions. All right, so the first thing, you typically sort your data into indices just to make it easier to search. Now, in this case, everything we need is this in one index called bots v1, which is boss of the SOC v1. So it's a good practice to put this in your queries, although in this case, it doesn't matter because that's all the data there is. Now, if you search now, you're going to find nothing because by default, Splunk searches only the last 24 hours of data, and all this data is several years old. So the first thing you have to do is adjust the time to go to all time. Now, that search will be very slow. Splunk searches, it's going to find a lot more than this. It's going to find almost 1 million events when it finishes, but it's going to take a while, especially when several students get here using it. So if you're doing a search with too many answers, the way to speed it up is to use event sampling here, where I only want to see one event out of every 100. That will make it much faster. And of course, I don't see every event, but if I'm doing a search that's going to have thousands or millions of answers, I'm only going to get an overview anyway. Now it finished fairly quickly, and it found 9,000 events because there are a total of 900,000 events. So here you see what these events look like. And see if I can get my scroll.
Sam, your mic's crapping out again. Can't hear you anymore.
All right, can you hear me over here?
Yes.
Any better?
Yes.
Okay, let me try and adjust my setup here to bring that computer closer. That's probably as good as I can do. All right, thank you for telling me. Is it audible? Looks pretty good.
Yes.
Okay, good. So here, you now I see the various types of types of data that exist, and the number of events that were found of these different types. So that's one way to see a summary. All right, so we saw source types and we talked about what they mean. So now let's look at the HTTP data. So I'm going to look at the HTTP stream data. So I look here for it, and there it is. If I click that, it will add that to the query. Now I could type it up here too. And as you can see, there's a pattern for this. You can put a word up here and it will just search for that word anywhere in the event, but that's very inefficient. It's better to have field name equals value. That's more efficient. So now I've found HTTP events. And these, if you scroll down, show you some pretty meaningful stuff. Here's the client IP address. Here's the destination content, which is some HTML. This was an HTTP request that apparently succeeded, and so on. You got the destination IP, you got a MAC address, and HTTP user agent, a lot of meaningful information here. So, all right, we've seen this client IP and so on. All right, so now this company has a web server, and the web server serves, this is the domain name. I'm really not Batman.com. So if you add that to the query back here, all right. The machine is a little slow, but not too bad. All right. All right, so I add that to the query. Now what it's going to do is look in this index, and for HTTP stream data, and I didn't put field name equals value, so it's just going to look for that string anywhere in the event. So I'll start that one. There we go. It's running. Okay, it found 228 events, and I'm still using sampling of 1 in 100. And by the way, you have a timeline here. You could click on, if you want to zoom into a particular time window. But right now I'm content to just use all time. And so let me see. All right. Now, if you just look at some of these events, you notice something here. This is obviously an attack of some kind. .. .. Somebody is attempting a directory traversal attack to point to win.ini. This is not normal web traffic. So this is being sent by some kind of attack product. And if you look at the HTTP user agent, looks okay. Some of these are more obvious than others. Now, if I get rid of the filtering and go back to seeing all the events now, then it should be easier to spot the source of this attack. Now I should get, I think, 9,000 events. Check my instructions. All right. Now, if I look down here, I can do it this way. Let's go here and look at the HTTP user agent. To click that, I can see what there are. These are web browsers. Here's somebody using a Python script. Here's other things coming through. What I'm interested in here is finding the name of the attack server. So you'll find it here. Many header fields reference a web vulnerability scanner. You'll see them in the source headers. Okay, so let me go down and find a packet that looks, this is obviously a SQL injection. Select 0 from select sleep. It's clearly trying to do a SQL injection here. So that is some kind of attack. And if I look at the headers, I should be able to find the source. Let's go down a bit and see if I can find one that reveals it. This post to, there we are. This is what I was looking for. It's all over the place. What happened here is an attacker ran a vulnerability scanner against this, this website. And they used a pirated version of Acunetics web scanner, and they didn't even customize it. And a commercial scanner will do this. It will put the name of the scanner all through all the traffic because they don't want people to mistake a legitimate scan for an attack by a criminal. So it's easy to see what scanner was used. So from any one of these you can find, you can now answer several questions here. So for example, we get back to this page, which is slow. Okay. So after you see how to use it a bit, you can start finding things. And here's a series of questions. What's the name of the scanner? Well, we saw that. That was easy. Then you want the attacker's IP address and the web server's IP address. And those you can find here. So this is data coming from the Acunetics scanner, sending this information. So the source of this would be the attacker and the destination would be the web server. So the web server is here starting with 192. And the source of this is this number starting with 40. So that gives you several of the flags you're looking for, and you can put them up here. Once you find a flag, notice which question it is. This is 1.1, was the name of the scanner. So you go up to here and submit the flag. And this is bots v1, 1.1. You choose the series of challenges. I'm going to use a name that won't show up on the scoreboard. And put in the answer. Submit that one. It tells me I'm correct. All right. And so you can put them in there and you'll appear on the scoreboard. So there are a few things to find here. So get started doing that. And I'm going to stop this video and then demonstrate some more stuff after some people get up on the scoreboard.